So, welcome all of you in today's session. I am Vijay Rahane, a PMR scholar at IIT Delhi, and today we are here to solve a problem based on the third week lectures, whatever taught by the Professor Amit Basar for the course of structure, stereochemistry, and reactivity of organic compounds and intermediate, a problem-solving approach. So, so we'll start with the uh, some problem initially, and in between we'll discuss some concepts. This is the problem from second week uh, topics. So we'll cover this some problem first, and then we'll go through the third week problem based on the third week topics. Right. So this one is the first question for today's discussion. Right. Uh, the question is the absolute configuration of ESP3 chirality center A and B and the axial chirality in the molecule are respectively. So what they have asked, we need to assign a absolute configuration for this center, and you can see here in this molecule there is a axial chirality. This is example of axial chirality, right? So we need to assign a absolute configuration for all these two centers and this third one. So we'll just give numbering first for one center one by one. So this one is the center. So we'll draw it here for our understanding, right? And here is this remaining part of this molecule, right? We'll label it as a group, right? And here is OH is methyl. So we'll give numbering to this. We can give a numbering like 1. This is this heteroatom goes to first priority goes to the OH group. The second priority goes to this group, this entire alkene group, and third priority goes to methyl, and hydrogen which present obviously below the plane, which is for this we will assign the fourth priority. And so what is configuration for this molecule? This center is this one, we can go it's clockwise, so it's R configuration. So configuration for this center is R, right? So similarly for the second center, what is the configuration for the second center? So we will draw exactly whatever given in the problem. So here is OH, here is methyl, and here is the group. We'll draw it like as a circle, right? Draw a little clearly. Right. In this one, we need to give numbering. So how the numbering will go? Numbering for OH, the first number, for the second one, and it has third one, and obviously the hydrogen is the below the plane. Fourth priority will go to hydrogen. So what is the configuration for this one? 1, 2, 3. It's anti-clockwise, and fourth priority will be below the plane, so it will anti-clockwise. It's S configuration. So it has S configuration, right? And for now, we need to assign the configuration for this one, the axial, this chirality axis, right? So we'll just move this all part. So we'll get here some space. So for this molecule, so to give the so this one is the axis, right? So we will see from this side, right? So if we see from this side, then so what we can see in if we see from this side, so we will give numbering to for this one. This one is first priority. It has second one. Similarly, in this one, it has R, it has S, so has R precedes yes, so it has one. So this is away from viewer, so it has third one, and this entire group has the fourth one. So this entire group, I'm talking about this entire group. Here also, this complete group. These are the four groups, right? Uh, So we are seeing from this side. So what will be the numbering for this one? So this one, you can see the hydrogen is above the plane, right? So here is hydrogen, and here is COOH. So it has second, it has first, right? And you can see, if you see from this one, this are at right hand side, right? So it has three, and it has here fourth one. So so the numbering will be like this. And if you see how it will be first, second, and third, that is it is clockwise, right? It is clockwise, that is R configuration. So the for A, B, and axial chirality. So what is to be the answer? First one is the R. For this B center, it's yes, and for axial chirality, it's again R. So answer will be R S R. Right. So this one is a problem from the second week topics. One more problem is there. So we'll look that problem also. Right. So this one is the problem. This belongs to the second week question. So second week topics. So what they have given, among the following molecule, which has the pseudo asymmetric center? Pseudo asymmetric center, right? So we have already seen this one. What is the pseudo asymmetric center? If the uh, a carbon atom having two different group A and B, and another uh, a group which have two different configurations. If it is having R, then second it will having the S configuration. Or if the one group one side having the S configuration, then second side should have the R configuration. If it is yes, then it should be R. Like this will be the condition for pseudo asymmetric center, right? So what is so we'll check one by one. So and eliminate, right? Uh, Here first structure they have given. In this one, you can see it has two hydrogen atoms. These two atoms are same, so it it will not a pseudo asymmetric center, right? Since these atoms are directly exactly same, it doesn't have a different composition. If the groups are same, but with the different composition, then we can say it will be a pseudo asymmetric center. But here we can say because of this hydrogen, this will be a not pseudo asymmetric, right? Now we will check second one. In second one, you can see right. This first group is different. This hydrogen. One is bromine. Second group is hydrogen. Now this side you can see here we will give a numbering. First one, this one will be two, and this one will be three. So it's R configuration, right? Here it's R, and for this group, the attaching group are same, but we need to check a comparison. So here is 0, 1, here will be a 2, and methyl will be 3, right? It's For this one, it's S configuration, right? R and S, right? So here we can see, we'll remove the unnecessary part. It has the one is the R configuration, and second side the group having the S configuration, and these two attaching groups are different. So this one will be the pseudo asymmetric center. This one is the right. This one is the pseudo asymmetric center. Now we will check whether another these remaining are the same or not. So we can check the configuration here. So it having the 1, 2, 3. So it's having the R configuration. This one also having 1, 2, 3. 1, 2, 3. It's clockwise. It's having the R configuration. These are the means these are the same group. So uh, this will be not a pseudo asymmetric center. Here also we can check configuration 1, 2, 3. It's R configuration for this one. For this one, 1, 2, 3. 1, 2, 3. This one is anti-clockwise, but the fourth priority group is upside, so we need to reverse the compression, so it will be the R. So these are the same group. Since these are the similar group, exactly same group with the same compression, so these are not a pseudo asymmetric center. So this is not a pseudo asymmetric center. So correct answer is second, right? So correct answer is B. Okay. So these are the some problems from the week 2 topic, which is taught by professor in second week. So we will see some problem based on now third week content, right? So this is the first problem from the third week. Problem based on the week 3, right? So here we need to check. The first question is, consider the following two statements. Here first statement is RCP and LCP, that is right circularly polarized and left circularly polarized rays have different refractive indices in dissymmetric medium. So this one is the first statement. What is the second question? And this statement, okay, if you see, this is one is the correct statement, right? Because RCP and LCP, that is right and left circularly polarized light have different refractive indices in disymmetric medium. This is the correct one. The second statement given, the RCP and LCP rays are absorbed in different extent in disymmetric medium. This is also the correct one. So what they have given, identify the correct statement. So statement 1 and 2 are correct. So we need to see the option which is which state that one. Statement 1 and statement 2 are correct. It gives rise to circular diaprism, and 2 gives rise to the circular biprisms. No. If you see this one, uh, the first statement, right? It gives a it represents circular. Right. This is because of this one. And in the second one, if you see the rays are absorbed in different extent in symmetric medium. This is because of the which phenomenon? These two different components are absorbed differently, right? Which cause difference in the electrical field vectors, which in turn will form elliptical polarized ray. Elliptically polarized ray, as professor already told. the difference in the electrical field. So this the resultant vector is called elliptical, right? Elliptically polarized. The ray will be the elliptically polarized. So in this one, this first option is not due to the right circular polarization and left circular polarization have different refractive index in this symmetric medium. This is because of the circular bifractance, and this RCP, that is right circular polarized light rays and left circular polarized ray, are absorbed in different extent. This is because of gives rise to circular diprism. So the option C is the correct option. So we will take a next question. So next question is, consider the following graphs and identify a correct statement. So the first plot is given. Uh, this plot, first you can see it firstly negative on the negative side, and then it came to a positive side. So which cotton effect? This one is the this one will be the negative cotton effect, right? Because it lie in the negative side, first decreases and then increases. So it's a negative cotton effect. The B curve represent a, as you can see here, it's a positive cotton effect, right? Because it's first it lie in the uh, above this plane, right? With the decreasing wavelength, you can see here it goes decreases, right? Firstly it increases and then it decreases. Here first increases then decreases, it's positive. Here first decreases and then increases, it's negative. And here you can see it's in plane. So this one is the plane, so it doesn't show any cotton effect. So which option is the correct option one here? What first option is, curve A show the positive cotton effect. Wrong, it shows negative cotton effect. So option first one is the incorrect one. Option B is the curve A represent a positive cotton effect. Sorry, curve A represent a negative cotton effect. This one is correct. Curve B represent positive cotton effect. This one also correct one. And C represent a plane curve. So this one is the correct option. Third option given, curve A represent a plane curve. Wrong. So this curve A is not a plane. It shows a negative cotton effect. Curve. So this one is the wrong option. B represent positive cotton effect. Up to here, this B part is correct, but this entire option is incorrect because of this A. They have written A shows the plane curve, not A doesn't show the plane curve. Option D is curve A represents positive cotton effect. This one is the incorrect one because curve A shows the negative cotton effect. So this is a simple problem based on the cotton effect. We just need to look at the graph, and by looking at the graph, we can say we can easily identify this example belong to which cotton effect, right? So we just need to keep in mind, if we go from a higher wavelength, this one is the higher wavelength. This higher wavelength to a lower wavelength, first increase and then decrease in line. First increase and then decrease, it show a negative cotton effect, right? It show a positive cotton effect. But here we can see here first it get decreased and then increase. So this one is the negative one. This one is the positive one, and this one is a plain. Sorry. We will take a next example. The third question, the next question is the consider the following two halo cyclohexanone following two halo cyclohexanone and identify compound that show positive Cotton effect. So we just need to identify which compound show the positive Cotton effect, right? So just we can directly plot this in the diagram as we already know, like this. But for see this simple one, I don't think we need to just we don't require to draw. We directly here we can see the carbon at the head of the chair, right? And if you see from this side, opposite side of this carbonyl, then what we can see, it is the on right side, the bromine group attached right side. But since we are seeing from opposite to the carbonyl carbon, so we need to take the opposite representation, like so. Here will be the carbonyl carbon. So if you give the numbering 1, 2, 3, 4, 5, 6, the first will be here, the second here we can see the second bromo in the right hand side, but it actually should be a left hand side if we look from this side, right? This one is 2, this one is 3, this one is 4, this one is 5, this one is 6, right? And the bromine at axial, so bromine is axial, so bromine will be here, and we can see this one is the negative, this quadrant will be a positive quadrant, this quadrant negative quadrant, this quadrant is a positive quadrant. So the first example, you can see this bromine lie in this one, so this one is the negative quadrant, right? Similarly, this one also you can see. For this one, what we can do, we will just draw a simple diagram, like in this one, just look at this one. This carbon is at not at the head of chair, it is at the leg. So we will directly see from this side, and no need to do a inverse, right? So if we do the numbering, the carbon 1, the chlorine 2, 3, 4, 5, 6. So here we can see the one goes to here and chlorine in the right side. So we will keep it as it is because this carbon on a leg of the chair. So we'll keep it here 2. So remaining carbon will be like as it is. Accordingly, we need to draw a remaining center, right? And where will be this chlorine belong to? The chlorine is equatorial, so this equatorial position will be in a plane, right? This chlorine is here. So you can see this one is positive. Sorry, chlorine is at axial, right? So axial will come here, and you can negative, positive, negative, positive. So this lie in the positive center, so it shows the positive particle. Similarly, this one also we can draw. We'll take a different color just to understand. Right, we'll take blue one. So here we can see uh, we need to see from this side, right? For this chain, if you see from like this, what we can see, we'll draw the, we'll give a numbering 1, iodine 2, 3, 4, 5, so is 6, right? So if you keep this one at this center, right? So where will be this 2 belong to? If you see from back side, then this 2 belong to right hand side. So here will be a 2, here will be a 3, 4, 5, and 6, right? So, and where this iodine attached, iodine is axial, right? So iodine is here, and we can where it is. This is in the negative, positive, negative, positive. This quadrant we should always keep in mind, since these are the rare side. So this sign of this quadrant is opposite to our Cartesian coordinate, right? So here is a negative one, and the iodine belongs to the negative. Sorry, I, this one is the positive one, so iodine belongs to the positive quadrant, so it shows a positive quadrant effect. And similarly, the last one, we'll take a different color to solve this one. Let's take this color, and here we can see from this one we directly see from this side what we can see. I will solve it here, right? Here I will solve. Let's give numbering for carbonyl 1, fluorine 2, 3, 4, 5, 6. So the carbon at 1, at right side we can see there is a fluorine, right? So fluorine here, third, fourth, fifth, sixth. So the fluorine attached right hand side and axial, right hand side 2 at axial, here is the fluorine. I think we have did somewhere mistake, but fluorine is here, but always keep in mind fluorine does not show cotton effect, right? So although it come, if you plot in this diagram, the fluorine comes fluorine, it like if any group like bromine chlorine will be there, then it will be a positive. But here we can since it's a fluorine, so this doesn't show a cotton effect, right? So this thing we need to keep in mind. So don't do any kind of mistake. Just for this example, since it's a fluorine, note note does not induce any cotton effect. This always keep in mind. Otherwise, you will make a mistake because of this fluorine atom. Right. So, which option is the correct? What they have, question is consider the following two halocyclohexane and identify compound that will show a positive cotton effect. So, which is this one is the B and C. Here they given B and C. Right. So, this option is the correct option. B and C show the positive cotton effect. A show a negative cotton effect. And D doesn't show any cotton effect because fluorine doesn't induce any cotton effect because of low polarizability of this fluorine. Right here I have given some explanation. So I will attach these slides also in the drive, so you can read this content as well. So the next question is, Following two bromo decalones are expected to show positive cotton effect, negative cotton effect. In short, we need to show which cotton effect this conformation show. So we directly draw a structures and then find out which cotton effect it shows, right? So I'll just check a chat section. So if anyone having a doubt, I can. So nobody having any doubt. So I'll just continue. So we need to draw a structure in a chair form so as we can find out the cotton effect, right? Which type of cotton effect shown by A molecule and the B molecule. So here we'll draw first A molecule. So to draw this A molecule, here we can see the hydrogen are the trans. So the chairs are the trans junction chairs. Wait. So I will just draw this molecule in a chair form, and the chair should be this junction should be an anti, right? So I will draw. Always make habit to draw a chair in perfect. So as here is the bromine atom, and here is the carbonyl group, right? So we can see from this side. I'll just draw a little. Right. So here we can see from this side. But keep in mind this what while since this carbonyl carbon at the leg of the chair, so leg of the chair, so we need to flip, or we can just keep in mind. So it's leg of chair. So whatever the compression it can, we need to just in opposite. We need to just change it, right? We can take the opposite one. So how it will be? So here we'll give a numbering for our just for simplicity. So numbering will be suppose here 1, 2, 3, 4, 5, 6, and the 10. And if you draw here the carbon carbon at the center, right? So number 1 will be here. We'll just keep some space. Right. On that you can see here, if you see from that side, right, we need to do opposite, right? So here we can see, if you see from this side, it looks at the left side, but it should be a right side D, and here 3, it will be 4, 5, right, and here will be a 10. For 10 and 5, for 10 it's at equatorial, 9 is attached, and at 5 at equatorial, 6 is attached, and remaining carbons, where will be the remaining carbon? 8 at equatorial, So we can exclude the remaining carbon, right? So what here can see, this one is negative, right? This one is positive. This one is the negative. This one is the positive, right? So what you can see, these all lie in the uh, positive quadrant, but this one is the leg side. So we need to interchange. It is the, since it show by this one we can see it show a positive cotton effect, right? But here, since it's on carbonyl carbon on leg of the chair, so we need to alter change. So it's the negative. So this show a negative cotton effect. And similarly, in this one, we will draw this conformation, this molecule also. So we'll take different color for this molecule, green for this one, right? So we'll draw a chair. Right. So here is chair, and here we can see similarly here. If you see from this side, right? In this one, sorry, we have not drawn bromine here. Bromine is at axial, so bromine will go here. Right. So here also you can see from this side what you can see here, this first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10, and here if you see from this side, the first carbon carbon is here, and on right hand side there will one. Here you can see right hand side bromine, but it should be a left because we need to see from back side. And here we can see here will be a 2, here will be a 3, here will be a 4, 5 is 10, and where remaining groups are at 2, there will be, you can see the bromine attached to where this bromine is going to attach at axial position, right? Bromine is attached to the axial position, and if you divide a quadrant like it is negative quadrant, this one is positive one, here is the positive one, and this one is the negative one. So this shown negative, but negative changes to positive because carbon carbonyl carbon at leg of chair, right? So this thing you need to keep in mind always. If the carbonyl carbon at the leg of the chair, then draw perform all the operations, and then whatever the composition it came, since what comparison here came, it came a negative one, but this negative we need to change, it will be a positive, changes to positive because of this carbon carbon if you see at the leg, right? Similarly we have also did here also, right? So which option is the correct one? So A is negative and B is the positive one, where the positive option A is positive quarter effect shown by A. Wrong. Positive component of both, no. Negative quarter effect show effect of A and positive quarter effect of B, right? This one is the correct option, right? So in this way we can solve a problem based on such systems, right? Now next question is the correct octane projection of the following molecule. The molecule they have given, and we need to find out correct octane projection. So what we can do, we can directly draw correct projection, and then we will match with these options they have given. This A option they have given, B option given, C option given, and this D options, right? uh, these four options they have given, so we need to check which option is the correct option, right? So we directly draw structure octane projection for this molecule, and then we will match with this. So we will draw a molecule first. So what is the molecule? The molecule is like this. So this methyl is at axial for upper side and hydrogen below, and carbon carbon is like this, right? So we need to draw a first we need to draw a chair for this one, right? So how the chair will look like? Chair will look like this. Correct. So here will be a carbon carbon, and right. So this one is the, yeah, methyl is axial. So we have kept numbering, and we'll give a numbering from this carbon. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and this one is 10 carbon, right? And now we will do a octane projection for this one. So this carbon at the, so we'll draw this carbon first, and what we can see, if you see from this side, like this, if you see through this direction, what you can see, this means second carbon is on the right side, right? This second carbon is on right side, the first carbon is here, so the remaining carbon and passes through the carbon 10. So the 10 carbon is on axis. Uh, so here will be a 4. These 5 will be left side only. And see, for 5 at equatorial, this 6 is attached. Means the 6 should be equatorial. And for 10, right? For 10, this 9 is attached at equatorial position. So for this position, we know for here, we'll just uh, draw a schematic so as you can easily understand. right? So for this position, the equatorial will be like this and axial is here. For this position, here is the axial, here is the equatorial. For this one, it's equatorial like this, axial like this. For this one, axial here and equatorial here. For this one, equatorial here and axial here. Just keep in mind, here is the, this one is the equatorial one. So, right. So this one diagram, just keep in mind while drawing this one. So how, where it will be the 9 will be here and remaining carbon will be accordingly, right? So where the methyl attached to the carbon number 10, right? And where it is attached, it acts on the axial position. So methyl will be here. And just rub this one and draw with this different color so that you can easily identify. Right, methyl is on axial side. So this one is the correct position for this, and then we will match with this the options, right? So which option? So this one is the correct. This one is the octane projection for given compound, right? So this one is the given compound, and octane projection for this one is the like this. So we will match with this option. So which option they have given? So here we can see this methyl at axial position and it lie on the left side from this, right? So we will neglect all other options. This one is neglected. This option is also neglected, and these two. Here we can see in D and this the methyl written upper side. So this one is wrong because of this methyl they have given upper, right? So here methyl they have given left uh, between 3 and 10. So is the correct option. So B option is the correct one. So this one is the correct octane projection for this molecule A. So this A molecule given for this one, the option B is correct option. The next question is the preferred conformation A for cis 2 methyl 2,3 dimethyl cyclohexanone show positive Cotton effect. Identify A. So what they have given, the cis 2,3 dimethyl cyclohexanone show positive Cotton effect, right? So identify A. So we need to identify A, right? So we need to find out which of these A, B, C, D show a positive Cotton effect, and then we can finalize which of this A structure of this A molecule, right? So we will draw all this one. Instead of drawing, we can directly see from this one. Uh, right. So we can directly see from this side. For this one, we can see from this one side. So what we can see, this methyl and methyl lie on the left side and carbon carbon at the center. So for this one, the carbon carbon, let's give numbering 1, 2, 3, 4, 5, and 6. This one at the center, and on the left side, there is one methyl is attached, right? Here at 2, at 3 position, sorry, and on the right side, the 6 atom attached. Here 5, 4, 3, right? at 3 at axial position, means this axial position, this methyl is attached. Uh, and the second methyl attached to 2, which is at equatorial, right? See, this in the both this one, these both are on the line, so it doesn't show a cotton effect, right? Because the it doesn't show a strong cotton effect because of this all lie on the axis. In this molecule, you can see, we'll take different color. Here we can see it will be number 1, 2, 3, 4, 5, 6. The one lie in center, and on sorry here I did a mistake. Since we are looking from back side, so we'll see this methyl 2, 3, 4, 5, 6, like this, right? And methyl attached here and here. Similarly for this one, this the P molecule, left side 2, 3, 4, 5, and 6. You can see at methyl, axially methyl is attached, right? At third position, equatorially methyl is attached, right? So here where this uh, compound belong to, so negative, this one is also negative. This one is positive quadrant, this one is also positive quadrant. So this show the negative cotton effect. Negative cotton effect. We'll take the next example. Here we need to see from this side. If you see from this side, then you can what you can see this 1, 2, 3, 4, 5, 6. The one is here, and on right hand side there is a methyl attached, which is equatorial. So here is 2 equatorial methyl, and another methyl attached axially. So this one attached axially 3. So these are on the axis, so they doesn't show a cotton effect, right? And the option D, right? Hmm, right. Here we can see at 3 position this methyl attached here, this methyl attached here. So what you can see here, negative, positive, negative, positive, right? So it shows a negative cotton effect, right? Because this methyl layer, the methyl negative side, negative cotton effect. This one show positive because this methyl at this quadrant. Negative, positive, negative, positive. So this methyl and positive. So this one is show positive one. This one is the negative one. This one also negative one. And last one. In last one you can see the methyl is at axial. If you see from that side, then it will be on left side, right? This 2, 3, 4, 5, 6, and at 2 where axial methyl is attached, and 3 equatorial methyl is attached. Since this axial methyl contribute more and this one is on the negative side, so this one also show a negative cotton pair. So the correct answer is the A option is the correct one, right? Because they have uh, we need to find out positive cotton effect. See, all others are negative, this one is a positive one. So the option A is correct option. Now we'll take a next question. Yeah, here is this explanation. Uh, Given numbering, and then we'll draw the octane projection, and because this methyl on the positive quadrant, so this show a positive quadrant effect. Right. Here the next question is, R methyl cyclohexanone show a positive quadrant effect. S methyl cyclohexanone show a negative quadrant effect. Identify most appropriate option. So they have given two compounds and they inform positive. The compound A show a positive copper quadrant effect, and this one show a negative quadrant effect. The identify most appropriate option. So the option given in both are methyl cyclohexanone and S methyl cyclohexanone occupies axial position. In R3 methyl cyclohexanone and S3 methyl cyclohexanone, methyl occupies equatorial position. In short, we need to draw a projections, and then only we can answer this question. So for this one, uh, we should draw a projection first, right? So I have already drawn some projection for this molecule. The compound will be like this, right? So what they have given, the name of the compound is R3 methyl, R3 methyl cyclohexanone show a positive quadrant effect, right? So we have drawn a structure, and since uh, these two, if you see from this side, the two on the left side, 2, 3, both are on the left side, and 6 and 5 on the right side. And here we can see this methyl is at equatorial position. So this methyl we have drawn on the equatorial position, right? And remaining are the same. Similarly, in the next uh, S configuration structure, this methyl will be on equatorial. These are the same example. You just need to figure out the structure and just draw octane projection. As we have already seen a lot of example on this octane projection, I will not spend more time on this one. So you can see both in the both this one, uh, both the structure, this methyl is on equatorial position, right? And for the second molecule also, the similarly, if you draw the structures, you can make a practice at home for this molecule. And if you have any doubt, just inform in the next session. So I will uh, show this molecule. I will solve this problem again if you are not able to solve this one, right? Here also, similarly, just look at from the side of the carbonyl, and this 2 and 3 carbon at a left hand side. So 2 and 3 you have given left hand side. This methyl is at axial, so the methyl lie here axial, right? Methyl will be at axial, and remaining carbon this one. So this one also show positive photon effect. And if you structure the second structure, this second possible structure. Here in this one, the group are at axial position at attach 3, and both are on the right side. So we have written it here, right? And accordingly, this methyl seems at axial, so we need to draw it at axial. And we can see this lie in the negative quadrant, because negative, positive, negative, and positive. These are the sign of the quadrant. So this methyl lie under negative quadrant, so it show a negative quadrant effect. It show a positive quadrant effect. Similarly, in upper first problem also, here it show a positive quadrant effect and it show a negative effect. Right. So that we can able to solve the problem now. What they have given in both cyclohexane, methyl cyclohexane occupies axial position. In both R methyl and S methyl, R methyl cyclohexane and S methyl cyclohexane, methyl group occupies axial position. No, you can see here. Here methyl is our equatorial positions, right? So this one is the wrong answer. The correct option for this one is the this one, since in the both one occupies the methyl group occupies the equatorial positions, right? As here we have seen, this methyl group are equatorial, this methyl group are at equatorial position. This option is the correct option. We'll take a next question. In the next question, here they have given, consider the following two conformational diastereomers of methanol. Menthone, right? And correct statement for this one, right? We need to identify. The first statement given, A and B show positive cotton effect. Second statement given, uh, A show negative cotton effect, B show positive cotton effect. Third question given, third option given, both show negative cotton effect. And fourth option given, the A show negative and B show a positive cotton effect. So we just need to find out which cotton effect this molecule show, and then we are able to solve the answer, right? So directly draw a structures for this molecule, and then identify which cotton effect this molecule show. For A molecule, I will draw it here up for A, and here lower for B. I will draw with the green color for A. If you see from this side, here just always keep in mind, when this uh, carbon at the leg of the chair, what are the our compression gap, we need to change it, right? So from this one, if you see, we'll give numbering 1, 2, 3, 4, 5, 6. So here will be the 1, that carbonyl, carbon 1. Left side, you can see here, here is 2, and at 2, equatorially, the group is attached, CHMe2, right? CHMe2 group attached equatorially. Here will be a 3, 4, 5, and 6, right? At the three position, at equatorial, methyl is attached. So in this one, which cotton effect is this group show? This A structure show, it show a positive cotton effect, right? And for because it show negative, positive, negative, positive. So the majority of this molecule lie in the positive side. probability, I will draw a expanded structure at 2 position. M this show a positive cotton effect, right? And the second molecule show, we will draw the structure of the second one also. If we see from this side, so what you can see, we'll do number 1, 2, 3, 4, 5, 6. The first carbon here, left hand side, there will be a group attached to CH, Me2, 3, 4, 5, and 6, right? So these are the structure, and at 5 number carbon, axially methyl group is attached. Since this one group lie in the negative quadrant, so it shows a negative quadrant effect, right? So the correct option is the D option, because A show positive quadrant effect, B show a negative quadrant effect. So the D option is the correct one. Right. We'll take two more question in this one. Right, here we can see the example. Yeah, here what they have did, they just carbonyl occupies leg position, so they while writing only they have drawn it opposite form, right? So the 2 will be on here right side, because this carbon on the leg side. So here you can see the 2 will be on the right side, and here, and then here negative, positive, negative, and positive. So here you can see the group show a positive cotton effect, right? Because both the groups are on the this methyl, you can see on positive side, as here also we have seen this on the positive. So we'll take a next example quickly. So here what they have the question given, consider the two enantiomeric forms of 3 chalcostanone, right? So these two structures A and B they have given, these are the enantiomeric form, and identify pair of octane position for A and B. So we need to identify correct pair of position for A and B. So these are the so we will directly draw a octane position for A and B molecules. So this one is little complex molecule, so I have already drawn the structures. I will just explain here how to draw. See, for this one, we need to see from this side, right? And for this one, we need to see from this side. For A molecule, we will draw first, and then for B molecule, I'll just take a one blank slide. Here, we will draw for A molecule first. See, for this molecule, we will draw. Since we can see here, carbonyl carbon on the leg of chair. So whatever the we see, we will do opposite. 1, 2, 3, 4, 5. We'll give a numbering first and then we'll start numbering with this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sorry, here is the 10. This one is the 11. This one is 12. This one is 13. Here is the 14. This one is the 15, 16, and this one is the 17. Right. So we have given numbering, and now it's time to draw projection. So the carbon will draw first. This third will be a carbon. So this direction we need to draw. Right. So I'll just keep drawing down some quadrants and all, so as it will be help in drawing the structure. Right. So since this carbon on the bridging side, right? Sorry, on the leg chair, leg of the chair. So whatever the we are seeing, we need to draw opposite. So this 4 and 5, we can see right side. If we look at from this side, but we should draw here while drawing. It should be on the left side. So 4 and 5 will be here, and the 10 will be here. Here we can see, here will be a 2 and 1 should be here. Right. Now here what we can see, at 5 carbon atom, here this group attached equatorially. So equatorially means this side, this 6 is attached here, right? And to this 6, this 7th is attached, and remaining chair we can draw. You can see this 10 attached to the 9, and 9 is on the equatorial position. For this center, equatorial will be here, so here will be a 9, right? And now remaining carbons are, where will be the, for this 8th carbon, 14 is attached, and which attached equatorially. So for here, this 14 will be here, 13 will be here, and 12, 11 will be like this. And methyl is axial at axial position, so this methyl is here. 15 will be here, right? And remaining here will be a 16, and 17 will be attached to 13, right? So since it's 5 membering, here will be no any carbon. So this one is the correct position, and you can see this one is the this one is the octane projection for this A molecule. So similarly, we will draw the octane projection for the B molecule, and you can see for B molecule here uh, we have covered this A molecule, right? Now we are going to see a B molecule. So the B molecule we will need to see from this side, and we'll draw. We'll give numbering first. It's 1, 2, 3, 4, 5, right? This one is 6, this one is 7, 8, 9, 10, 11, 12, right? This one is 13, this one is 14, 15, 16, 17. So the carbon carbon, if you see from this side, carbon carbon of the chair, leg of the chair. So here it will be whatever we are seeing, we need to just do the opposite. It means this 4 and 5 on the left side, we need to draw it on the right side. So here will be a third number. We'll draw just, we'll start from this side. You can see this fourth and fifth will be on right side, because this carbon will carbon at the leg of the chair. So although it looks here and left side, but we need to draw it here on right side, right? The remaining will be here. This one is the 3 is the carbon carbon. So remaining is the, sorry, 2, and here will be a 1, right? And here we can see remaining the axially this 9 carbon is attached, then 2 9 equatorially, the 8 is attached, 6 attached equatorially, and to this 13 is 17 is attached, right? To the 17 there R group, and since it's a 5 member ring, there will be no carbon in between here directly. This 16. So this one is the correct projection for the molecule, right? So you just need to do a practice for this one. So this how we can solve any problem based on this octane projections of different polycyclic systems. We have some time. We can take one example, another one example. So we'll take a last example for today's session. The problem is the which of the following cyclohexanone derivatives has occupant in front octane respect octane projection, right? Which of the following cyclohexanone derivative has occupant in the front octane in their respective octane projection? So as we already seen, since we are looking the carbonyl carbon, right? This carbon carbon, we need to we are looking from this side of plane, right? From this side. So maximum in maximum cases, the whatever the chair and all part goes to the back side, right? So here we need to identify which part is there on the front side, right? So we need to find out example of front octane. So like in this region, front octane, and in the formula here is the carbonyl carbon. If it is here carbonyl, and we need to find out this in this space we need to find out, right? So we'll just look at these molecules and just put a plane. So as we can see, the where it is the molecule lie. So if this molecule say if the plane passes through this one, so here we can see, is there any substituent on the front side? No, here is no any front side, right? So this one is not an example of front octane, right? In this second one, this on the leg. So if you pass a plane, so here will be a plane. The plane will be like this. I will just little zoom the structure so as you can able to visualize easily. Right. So in this one, you can see here For the first example, here will be a plane is passes through like this. So there is no any atom in the front side. So it is example of it is not example of there is no any occupant in the front octane in this example. If you see this plane you can see this plane will be like this, right? So for this molecule, we can see this part of the ring comes to a front side. So it's a example of front octane. This one is the front octane. Here, this one is not. This B has occupant. This C, for this C, you can see the plane will be like this, right? So this one is the plane. So it doesn't. It also not having the. Although it's while writing, I can see like this will be a plane. So here also there is no any occupant in the front side, right? And in this last example also, you can see the plane directly passes through this carbonyl and all occupants are on the back side, not on the front side. So the B is the correct option. Yeah, here with explanation, here I have explained in this one. So we just go through these slides. I will attach these slides also. So please share if anybody having any query for today's session or any query related to the topics covered by professor. Any doubt you can we can clarify. I will just stop recording so that you can really tell your doubt, share your doubt. So